Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that a compound DC generator delivers a current of 50 ampere at 500 volts and the resistance of armature, series and shunt fields are 0.05 ohms, 0.03 ohms and 250 ohms respectively. Compare the generator induced EMF when fully loaded in long shunt generator and short shunt generator. So solution. So first we are going to draw the sketch of the circuit of the long shunt generator. So the sketch is like this. There's a field resistance here. Here there's a series resistance. Then here is the armature. There's a brush here. A brush here. Then inside this armature there's an armature resistance. And there's the induced EMF. Then here's the load resistor. So this is the long shunt generator. Here is RF, the series and shunt field. Here is the shunt field. So it's known as RF, which is equals to what? The shunt fields are what? Is 250. So shunt field is 250 ohms. Then here's the series resistance is RSE. It's equals to what? The series resistance is this one, 0.03. Let me write under here, 0.03 ohms. So here is the what? Here's the armature resistance RA. RA is what? Is 0.05 ohms. RA is 0.05 ohms. Here is the induced EMF EG, or the generated EMF. Here is the shunt field. It can also be named RS or RF. So here are the brushes. Usually the brushes are assigned 1 volt each. So 1 volt. Finally, here is what is RL. That is the load resistor, which is what? The load resistor is not given here. So we are going to find this. Then the compound DC generator delivers a load current of 50 ampere. That means usually from this armature there's an armature current IA. The current flows from this armature. Then when it comes to this node, it branches. Here becomes IF. Here becomes what? IL. So for the brush, we're going to assign 1 volt each to it. So IL. Now IL is equal to what? 50 ampere. And the voltage here is what? Is 500 volts. That means the voltage here all through is 500 volts. Let me use a dotted line. You can say the voltage here is what? Is 500 volts. Voltage here is 500 volts. So usually the standard value of voltage for each brush in DC generators and even DC motors is usually taken to be 1 volt per brush. So in all the calculations involving DC generators and motors, we usually take 1 volt per brush. So sometimes it can be given in the question. Even though it's not given, just take 1 volt per brush. In this question, it's not given, so you take 1 volt per brush. So now, first let's find this RL. we have the current entering this branch and we have the voltage. So we know that R is what? This R, let me do it here. RL is equal to what? Is V over IL. This is from Ohm's law. That is V is equal to IR. V is equal to IR. So this becomes what? 500 over 50. This is what? 10 ohms. So this is 10 ohms. Here also is 10 ohms. So now we can also find IF. The voltage here will also be the voltage here in this long shunt generator. So we can say that IF now will be equal to V over RF. So what is V? V is the same thing. 500 over RF is what? Is 250. So this is what? Is 2 ampere. So IF is what? Is 2 ampere. Then we can find IA. IA using Kirchhoff's current law. IA is equal to what? IF plus IL. We have IL, we have IF. So it's what now? IF is what? Is 2 plus 50, which is what? 52 ampere. IA is 52 ampere. So now we can find the induced EMF. Now the induced EMF is what? Is EG. Is given by the original voltage plus IARA is the voltage of the armature plus what? IARSE. IARSE is the voltage, is the series voltage. You know the same current passes through this. You know the same armature current that passes through this armature resistance will pass through this series resistance. You know that is the same current IA that flows through this RA that will also flow through this RSE. So IA times RA will be here. Then IA times RSE will be here. Then the other voltage remaining is this 1 volt and 1 volt, which is together is 2 volts. So we can say plus 2. That is this 1 plus 1 here, which is 2. As I said before, it is the standard voltage for brushes in DC generators and motors. So this becomes what? We can factorize this for easy calculation. This becomes what? This is 500 plus what? What is IA? IA is 52. Then RA is what? RA is 0.05. Then plus RSE is what? 0.03 plus 2. 500 plus 52, 0.05 plus 0.03 plus 2. This is 506.16. So this is what? The generated or the induced EMF is 506.16 volts. So for a long shunt generator configuration of this question, this is the answer. So now let's draw the circuit. It becomes like this. So this is the short shunt version of this generator. Whereas in this case, this field or shunt resistance is connected from here to here. Here is connected in parallel only to the armature resistance. In this one, the shunt field is connected in parallel to the series connection of this and this. Here is only connected in parallel with only the armature. It does not include this. So it's from here to here. So here is the same thing. RF equals to 250 ohms. RA 0.05 ohms. RSE is what? 0.03 ohms. This is also standard 1 volt and 1 volt standard brush EMFs. Then this is the generated EMF. This is the voltage 500 volts, and here RL. So here there is IA, here there is IF, and here there is IL. So now, since this IL is given, so it's 50 ampere, this current will flow through this resistor, and the voltage here is 500 volts. RL is also equals to what? The voltage V over IL, like here. So and it's equals to what? 500 over 50, which is 10 ohms. Then now, to find IF. Now, in this case, the voltage here was equal to the voltage here because the circuit started from the same point, but now the point of this circuit has reduced from here to here. That is, this circuit now, this RF now is from here to here. So it cannot be the same with the voltage from here to here. So we have to find the voltage here. And the voltage here is the voltage across this branch. So now, to find the voltage here, we have to add the voltage of this resistor and the voltage of this series resistor. So if we add the voltage of this and this, we'll get the voltage here, which is the voltage across this branch. So now, the formula we're going to use is VF is equals to what? The series voltage. This is the series voltage, this one. Plus VL. So the formula we're going to use to find the voltage here is the voltage here, that is the voltage here, VF, is now equal to the voltage of this series resistor plus the voltage of this load resistor. So now, what's the voltage of the series resistor? You know, IA, when IA comes to this, when IA arrives at this point, it splits into two, according to KCL. So the current that will pass through this series resistor now is IL. So IL passes through this series resistor, IL also passes through this load resistor. So the voltage of VS is what? Will be IL times RSC. Plus the voltage here is already 500 because even 50 times 10 is what? Is 500. So you see, 50 times 10 is 500. So this 50 times 0.03 will give us the voltage here. So this one is automatically 500. So VF is equal to this plus this. Now, this VF is what? Is also the same thing as IF times RF. So we can say VF is what? Is IF times what? RF. And RF is what? Is 250. So we can say that it's IF times 250, which is equals to what? What is IL? Is 50. What is RSE? Is 0.03 plus 500. So IF becomes what? IF becomes this divided by 250. 50 times 0.03 plus 500 is what? 501.5. 501.5 divided by what? This is 501.5 divided by 250. This is what? 2.006 ampere. 2.006 ampere. Then we have found IF and we have IL. So now we can find IA. IA is what? IF plus IL. So this what was IF? IF is 2.006 plus what? IL is what? Is 50. 50. This is 52.006. This is 52.006 ampere. Then now we can find the induced EMF. EG is what? This is the formula. V plus IA RA plus, now you know that in this long shunt generator, it is the same current IE that passes through RA and RSE. That is why the formula is like this: IARA plus IARSE. Now in this one, the formula changes slightly. Instead of IARA plus IARSE like this, now this one becomes, you know that this current IA only passes through this RA, which is the armature resistance. Now here it is IL that passes through RSE. So now the current IL, it is the one that passes through here. So the formula now changes to IARA plus, which is IARA. The formula now changes from this to IARA plus IL RSE. So here now becomes what? Plus IL RSE, which is 2 volts standard. Then, so now you have to be very careful in the formulas. You have to make sure that the current that flows through the resistor is the one that are going to multiply by that resistor. Because here IA flows through both of these resistors. That's why the formula is in this way. And this one, it is IA does not flow through this resistor. It divides at this point into IF and IL. It is IL that flows through this. Hence the formula. So now we can substitute the parameters. This becomes 500 plus, what is IA? IA is 52.006 times, what is RA? RA is what? Is 0.05. Then plus, what is IL? IL is 50 ampere. 50 times, what is RSE? RSE is what? Is 0.03. RSE is 0.03, then plus 2. So this becomes what? 500 plus 52.006 times 0.05 plus 50 times 0.03 plus 2. This is 506.1003. 506.1003 volts, which is approximately 506.10 volts. So for the long shunt generator, the induced EMF is 506.16 volts. For the short shunt generator, the induced EMF is 506.10 volts. Now that means that the EMF of this short shunt generator is slightly less than the EMF of this long shunt generator, with only 0.06. So we can conclude that the induced EMF of the short shunt generator is slightly less than that of the long shunt generator. So the induced EMF of the short shunt generator is slightly less than that of the long shunt generator. As can be seen, that of the short shunt generator is 506.10 volts, and that of the long shunt generator is 506.16 volts. So this is how to solve a long shunt and a short shunt DC generator configuration. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.